Hello and welcome. Today, we're jumping into a battle that's happening in math classes all over the world. But it's not a battle with numbers, it's a battle with words. We're going to explore that really tricky place where language and mathematics meet.
Just for a second, I want you to imagine you're back in school, staring down a really tough algebra problem. Now, what if the textbook, the teacher, and even the concepts themselves were all being explained in a language you don't actually speak at home? All of a sudden, the challenge isn't just about the math, is it?
You know, we've all heard that saying, math is the universal language. And yeah, sure, 2 plus 2 equals 4, no matter where you are on the planet. But here's the thing. The way we learn math, the process of talking it out, explaining it, really getting it, that is anything but universal. It's totally connected to the specific words we use, and that's where our story really kicks off.
And to see exactly how this plays out, we're going to travel to a primary school classroom in South Africa. This was the setting for a really groundbreaking study that completely challenged the old idea that a student's home language was some kind of problem that needed to be fixed in the math classroom. So why South Africa? Well, just look at this number, 11. That's how many official languages there are. And this, it's not just a statistic. It's the day-to-day reality for teachers and students. You can just imagine how incredibly complex that makes the learning environment. So what we're talking about here is what's called a multilingual classroom. This is a space where students might speak one language at home, but the official language of the school, say English, might be a second or even third language for pretty much everyone in the room. And that often includes the teacher too. And this is the exact situation that researchers Mamagethy Satati and Jill Adler decided to tackle in their huge paper, Between Languages and Discourses. They actually went inside these classrooms to see what was really going on, and what they found would pretty much reshape how we think about language and learning.
Okay, so let's get to the core idea of their research. They basically frame this whole thing as a tension between two totally different worlds of words, our everyday language on one hand, and what's called mathematical discourse on the other.
And this chart here really breaks it down. See, on one side, you've got everyday language. It's messy, it's flexible, it's packed with social context, it's how we talk to our friends and family. But then you've got mathematical discourse. It's the complete opposite, super precise, abstract, formal, a language that's built for pure logic. Honestly, they're almost like two different languages entirely.
And this example just nails the point. Think about the word borrow, right? If you borrow a cup of sugar from your neighbor, the understanding is you're going to give it back. But when you borrow a 10 in subtraction, well, you are not giving that back. It's the exact same word, but the mathematical meaning is totally different and fixed. You can see how confusing that would be for a kid.
So, this raises a massive question, right? If students are trying to live in these two different worlds of words at the same time, how on earth do they learn complicated math? How are teachers and students supposed to bridge this giant communication gap day in and day out? Well, the answer, it turns out, is in something Satati and Adler identified as language practices. And this isn't just about speaking one language or another, it's about how you actively use language as a tool to actually build understanding. So what are these language practices? Well, they're the smart, strategic moves students make on the fly, using every single language skill they have to figure out a problem. And here's the key part. What might look like confusion or a mistake to an outsider is actually a really sophisticated learning strategy. Let's look at a real-world example of what this looks like. So the teacher might introduce a problem in English, which is the official school language. Then the kids turn to each other and they start discussing it, arguing about it, working through it, all in their home language, like Zulu. That's where the deep thinking is happening. And then finally, one student will figure out how to say it, and they'll share the answer with the class back in English. It's like this fluid, three-step dance between languages. And this is the most important point of all. This switching back and forth between languages, it is not a sign of confusion. It's an incredibly smart, cognitive tool. The students are literally using their home language, the language of comfort and real-world context, to build a bridge for themselves into the formal, abstract world of math.
Okay, so that's what's happening in one classroom in South Africa. But why does this matter for the rest of us? Well, because the insights from this one study have huge implications for how we think about education everywhere.
I mean, the takeaways here are massive. First off, this research proves that a student's home language isn't a barrier to learning, it's a powerful asset. It shows us that talking in the classroom isn't just about communicating, it's the very tool we use to think. And this means that teachers have to be way more flexible, and that, frankly, our educational policies need to catch up with the reality that so many of our classrooms are multilingual.
And that's really the end goal, isn't it? When we actually understand and value these complex language practices, we can stop seeing multilingual students as having some kind of disadvantage. Instead, we can see their strengths, and we can start building classrooms that are smarter, fairer, and just plain more effective for every single student.
So, I'll leave you with this final question to think about. If math really is a universal language, then who's supposed to be the translator? Is it just the teacher's job? Or maybe, as this research suggests, the real magic happens when we empower students to be their own translators, using all the rich languages they already know to build that bridge for themselves.